Hello everyone. So, this is the first lecture on conic sections. So, in this chapter conic sections we will study about parabolas, ellipses and hyperbola. So, let us start with we will discuss parabola, ellipse, and the hyperbola, and a special case of ellipse is circle, which you have already studied about. So, let us start with first circle. Let me recall what a circle is. So, a circle is a set of points in a plane which are equidistant from a fixed point in the plane. So, there is a fixed point, let us call C in the plane, and then to determine a circle we need all the points which are at a fixed distance from this fixed point. So, let us say the fixed distance is r. Then if we look at set of all points which are at distance r from this fixed point C in this plane, we get what is called a circle, and this fixed point, the fixed point is called the center of the circle, and the fixed distance of points on the circle from the center is called the radius of the circle. So, you would have also seen how to find equation of a circle given the center and radius. So, let me just briefly recall. So, suppose the center C is at a point h comma k and the radius is r. Now, if I take a general point P whose coordinates are x comma y, then let the center be C whose coordinates are h comma k and radius be r. This is some positive real number. Then to find the equation of this circle we use the definition. So, we know that the distance P C is equal to r, and then by distance formula we have the distance between the point P and C is x minus h square plus y minus k square square root, this is equal to r, and therefore, x minus h square plus y minus k square is equal to r square. This gives the equation of the circle. Right. So, any point on the circle satisfies this equation. Conversely, if x comma y satisfies the above equation, then the distance between x comma y and the center h comma k is square root of x minus h square plus y minus k square, which by this equation is equal to square root of r square, which is r. Thus, this equation, thus the above equation, let me call this equation star, is the equation of this circle whose center is at h comma k and radius is r. So, now let us discuss some other curve. So, we will discuss what is called a parabola. So, the definition is a parabola is the set of all points in a plane that are equidistant from a fixed line. Let us call this line L, and a fixed point and we require this point not to lie on the line, not on the line L in the plane. So, let me describe this geometrically. So, suppose I have a line L and there is a fixed point, let us call that point F. So, this point F and the line both lies in this plane xy plane, and we are looking for all the points in this plane such that the distance of the point from this line, that means the perpendicular distance of the point to this line, is equal to the distance of the point P to this point F. So, if we draw this, so you can see one point is clearly, if I draw this perpendicular line here, and if I take the midpoint here, then the distance of this point to the line is equal to distance of this point to this point F. Similarly, if you see, if you draw this curve, you will get a figure which looks like this. So, if I take any general point P on this curve, then the distance of this point P to the line is equal to the distance of P to F. So, if this distance is d, then this is also equal to d. So, we look at all the points which satisfies this, and this will give me a curve which is called parabola. So, this line L, the line L is called the directrix of the parabola, and the point F is called the focus of the parabola. We have directrix and focus. Also, the line passing through the focus and perpendicular to the directrix is called the axis of the parabola. So, if I draw again this line, and then I have this parabola, I have this focus F, this is line L. So, axis is the line which is perpendicular to the directrix and it passes through this focus. So, this is called the axis of the parabola. Now, this axis will intersect the parabola at some point which is called the vertex of the parabola. So, the point of intersection of the axis with the parabola is called the vertex of the parabola. So, we have axis, this is focus, this V is the vertex, this line is called the directrix, and this line which is perpendicular to the directrix and passes through focus is called the axis of the parabola. So, now we will try to derive equation of parabola. So, let me first discuss some standard equations of the parabola. So, right now we will discuss the parabola whose so we will discuss parabolas whose vertex is at the origin and the directrix is parallel to one of the axis, one of the coordinate axis. So, let us see. So, let me draw the x y axis. This is x axis, y axis. What we want is that the vertex should be at the origin. So, this is my origin O, and suppose the directrix is parallel to the y axis. So, let us take this to be directrix line L. Then where is focus? So, focus will be on the x axis in this case. So, let us say the coordinate of this focus is a comma 0. Then what is the equation of this line L? If you see the distance of this point vertex which is on the parabola to focus, this distance is a. This distance is a. So, the distance of the vertex to the line, this should also be equal to a, and therefore, the equation of this line is x equal to minus a. So, this is the case where my focus is f a comma 0, directrix is the line x equal to minus a, and vertex in this case is the origin 0 0. Now, if you draw the curve, so we want any point x y whose distance. So, if this is general point P x comma y, the distance of this point to the focus should be equal to the distance of the point from this line L. So, let us say this is point M. So, let P x comma y be any point on the parabola, then the distance of P from the focus F which is a comma 0 is equal to the perpendicular distance of P from the line, from the directrix, whose equation is x equal to minus a. That is, in the figure we have P m is equal to P f. Let me draw this figure again. This is the directrix x equal to minus a, and focus is at a comma 0. Now, any point P Now, what is the perpendicular distance P m? This is nothing but the distance of this point x comma y from the line x equal to minus a, which is equal to this distance. If you see, this is equal to x and this is, so this will be equal to x plus a in modulus, and the distance P f is equal to the distance of the point x comma y to a comma 0, which is square root of x minus a square plus y square. So, we get square root of x minus a square plus y square equal to mod of x plus a. Squaring we will get x minus a square plus y square is equal to x plus a square, which implies x square minus 2 a x plus a square plus y square equal to x square plus 2 a x plus a square. So, we see that x square and a square cancels, and then we get the equation is y square equal to 4 a x. This implies y square equal to 4 a x. And we assume that a is a positive real number in this case. So, this is the equation for the parabola whose focus is on the positive x axis and vertex is at the origin. So, this is the equation y square equal to 4 a x. So, here vertex is at the origin and the focus lies on the positive x axis. So, this is one of the standard form of parabola. This is a parabola which opens to the right. Also, what do we see in this parabola? This is symmetric about the x axis, and x axis is actually the axis. This is the axis of the parabola in this case. X axis, which is the axis of the parabola. So, this is symmetric means that if I have any point x comma y on the parabola, then we also have the point x comma minus y. This also lies on the parabola. This can be easily seen from the equation also, because if x comma y lies on this equation, we have y square equal to 4 a x, and then if I put x comma minus y square is same as y square. So, it also satisfies. So, we will see some more form of the parabola. So, it might happen that we have again we are taking vertex at the origin, and suppose my focus is on the negative x axis. So, f is minus a comma 0. So, now we have now consider the parabola whose vertex is at the origin and the focus lies on the negative x axis. Say f has coordinate minus a comma 0, where a is positive. So, in this case what will be the directrix? So, if we see the distance of the vertex from the focus, this is equal to here mod a is the distance. So, the directrix will be perpendicular to this axis. Axis is the line joining the vertex to the focus. So, the directrix will be line x equal to constant, and in this case this is the line x equal to a, and this distance we are taking a positive. So, this distance is also a. So, in this case the parabola, let me draw in red, passes through this vertex O, and this will open to the left. So, we get a graph like this. So, in this case if I take any point p x y, be any point on the parabola, then again we have the distance of this point. If I take p here to this line, this is the point, this is p x comma y. So, this is x equal to a and y. So, the distance p m is equal to p f, that is x minus a mod, this is equal to the distance of p to f will be x plus a square plus y square square root. Again by squaring we get x minus a square equal to x plus a square plus y square, and this will give y square equal to minus 4 a x. So, we can see in the previous one where the focus was on the positive x axis, we have y square equal to 4 a x, a is positive. So, in this case a can never be negative, because we have square equal to 4 a x. So, x is equal to y square by 4 a. So, x is always non negative in this case, whereas in this case we have y square equal to minus 4 a x, because a is positive, x can never be positive in this case. So, this lies completely in the left half plane and this lies in the right half plane. So, this is the equation of this parabola, where the focus is on the negative x axis and vertex is at the origin. Similarly, we can have focus to lie on the y axis. So, focus on the y axis. and vertex at the origin. So, suppose focus f is on the positive y axis, 0 comma a, and vertex is at the origin, then what is the directrix? If we see the distance of this vertex to the focus, this is equal to a. So, the directrix will be the line y equal to minus a. Now, if you take any point, so this parabola will look like this, which opens upwards. So, any point p x y on the parabola should satisfy that distance of p to f is equal to distance of p to this line. So, in this case p f is equal to square root of x square plus y minus a square, and p m is this point m is x comma minus a. So, the distance is y plus a in mod. So, p f equal to p m is equivalent to writing x square plus y minus a whole square equal to y plus a square, which gives x square equal to y plus a square minus y minus a square, that is x square is 4 a y. Similarly, if focus f is at 0 comma minus a, then the equation of the parabola is x square equal to minus 4 a y. So, these are 4 standard forms. We had this is y square equal to 4 a x, then we have y square equal to minus 4 a x, this is x square equal to 4 a y, and the other one will be this graph should pass through the vertex O. So, this is the parabola x square equal to 4 a y, and if my focus is on the negative x axis, then we get parabola facing downwards. This equation is x square equal to minus 4 a y. So, in subsequent lectures we will also discuss about more general form of parabola, where the vertex need not be at the origin, and also the directrix need not be parallel to any of the coordinate axis. But right now let us discuss some other term, which is called the lattice rectum of the parabola. So, let us take say this parabola. This is my parabola x square y square equal to 4 a x, and here the focus is at the point a comma 0 and the vertex is at the origin. Now, the lattice rectum is the line segment which is perpendicular to the axis of the parabola. So, this is the axis of the parabola here, and it passes through the focus. So, this line segment here, let me call this A B. So, lattice rectum is the line segment A B which passes through the focus F and is perpendicular to the axis of the parabola. And has end points on the parabola. So, in the figure A B is the lattice rectum of the parabola y square equal to 4 a x. So, we would like to find the length of this lattice rectum. So, what is the length of So, what we can see from this figure, what are the coordinates of this point A and B? We have focus is the has the coordinate a comma 0. So, this line is x equal to a. So, the what are the coordinates of this? So, let us say this is a comma minus y and this is a comma y. The x coordinate is a and y coordinate we are taking y here, then this will be minus y. So, because we have equation of the parabola is y square equal to 4 a x, putting x equal to a gives y square equal to 4 a square, which means y is plus or minus 2 a. So, this point is a minus 2 a and this is a comma 2 a, this is the focus a comma 0. So, the length of the lattice rectum L is equal to 4a. This length is 2a and this is also 2a. So, 4a is the length of the lattice rectum. Let me discuss one problem. Find the equation of the parabola which is symmetric about the y axis and passes through the point 2 comma minus 3. So, let us look at how this will look like. So, if I have x axis and y axis, what is given to you is that the parabola is symmetric about the y axis. So, because it is symmetric about the y axis, that means that this will be y axis is the axis of the parabola. This is the axis of the parabola. So, since y axis, since the parabola is symmetric about the y axis, y axis is this axis of the parabola, and the vertex is at origin. So, we have the vertex is here and this is the axis. So, therefore, this will be either facing upward like this, or it will be like this. So, we have to determine which one is this, but what we know is also is that the parabola passes through the point 2 comma minus 3. So, where is 2 comma minus 3? This point is in the fourth quadrant. So, this point 2 comma minus 3 lies somewhere here, 2 comma minus 3. So, therefore, the parabola facing upward is not what we are looking for. We are looking for this parabola which faces downward. So, we have to find the equation of this parabola which passes through 2 comma minus 3. So, we know the general equation of this parabola is x square equal to minus 4 a y, right. This. So, we do not know what a is. So, we need to find this a. So, the equation is x square equal to minus 4 a y, and then putting, since 2 comma minus 3 lies on the parabola, we have 2 square equal to minus 4 a times minus 3, and this gives A is equal to 1 by 3. So, therefore, the equation of the required parabola is x square equal to minus 4 times A is 1 by 3 y, that is x square is minus 4 by 3 y. This parabola satisfies the given conditions that it is symmetric about the y axis and it passes through the point 2 comma minus 3. Now, let me give you some idea about finding the equation of parabola when the vertex is not at the origin or the directrix is not parallel to the coordinate axis. So, in general, how do we do that? Given the focus and the directrix. So, let us say we have this line L is the directrix and the focus is at some point f is some alpha comma beta. Then how do we get the parabola? So, this line L, let us say this has equation a x plus b y plus c equal to 0. So, let the focus be f alpha beta and the equation of the directrix be a x plus b y plus c equal to 0. This is the general form of any straight line. So, now if you see the vertex will be midpoint on the line segment which is perpendicular to this L and passes through focus, and the axis is, this will be the axis of the parabola and the vertex is this point, say V, and if you see in this case the parabola will be symmetric about this axis. So, it will look something like this. Now, how to find the equation? So, if we take any general point P x y, let P x y be an arbitrary point on the parabola. Then we have distance P f should be equal to the perpendicular distance P m. So, then P f we know is x minus alpha square plus y minus beta square root, and Pm is the perpendicular distance of the point P x y from the line a x plus b y plus c equal to 0. This again you must have seen this formula will get Pm equal to a x plus b y plus c in absolute value divided by square root of a square plus b square. So, we have P f equal to P m. This is equivalent to writing x minus alpha square plus y minus beta square. If we square both sides, this is equal to a x plus b y plus c square by a square plus b square. This can be written as a square plus b square times x square plus y square minus 2 alpha x minus 2 beta y plus alpha square plus beta square. This is equal to a x plus b y plus c whole square. So, this is a square x square plus b square y square plus 2 a b x y plus 2 a c x plus 2 b c y plus c square. And this you can simplify further and write it in this form. So, this can be simplified and it can be written as b square x square plus a square y square minus 2 a b x y minus 2 alpha a square plus b square plus a c x minus 2 beta a square plus b square plus b c y plus a square plus b square times alpha square plus beta square minus c square equal to 0. So, you do not need to remember this formula, you just need to remember what is the definition of a parabola. So, if you are given equation of any line which is the directrix and you are given focus, then you simply use the distance of the point to the focus is equal to the perpendicular distance to the line, and then you obtain the equation of the parabola. So, we will stop here. In the next class, we will learn about ellipse. Thank you.